Hi, it's Pauly G back with another math question. This one asking me to differentiate this really interesting function. I love this problem because it involves one of my favorite rules in math, and that's the throwdown rule. Okay, so the throwdown rule involves logarithms, or here as I wrote, natural logarithms, which is the ln of a to the b power. And you can actually, what makes this rule so powerful is that you can actually make a coefficient, you make an exponent a coefficient. The problem that we have with the what you want me to differentiate here, f of x equals the cosine of x plus 3 to the with tangent as an exponent, is that, wait, how do I deal with the tangent of x? You would be wrong to use the power rule here. You can't just use the power rule with that. So, for example, if I had the ln of, I don't know, 2 to the third power, I can throw the 3 down and make it a coefficient in front of the natural log. Okay, so it's 3 times the ln of 2. Okay, so what we're going to do here is we have y equals the cosine of x plus 3, and then all of that is raised to the power of tangent of x. Well, what's going to happen is we're going to take the natural log of both sides. What you do to one side, you must do to the other. So I'm going to say the ln of y equals the ln of cosine of x plus that's an x, plus 3 to the tangent of x. Okay, and at this point, just like I took the 3 here and threw it down, I'm going to take the tangent and do the throwdown rule. Hey, okay, so the ln of y equals tangent of x times the ln of cosine of x plus 3. Perfect. So that was the critical thing here. This also, what I also love about this problem, it also involves the chain rule, a lot of chain rule. It also involves the product rule. Now, I don't know where you're at with calculus, but if you don't know, if you have f times g, to differentiate that would be the derivative of the first times the second plus the derivative of the second times the first. Okay, so we're going to differentiate. We can differentiate now. So we can differentiate the left side. Remember, ln, the derivative of ln of x is 1 over x. Okay, all right. And then we would differentiate the inside, differentiate the x. Well, the derivative of x is 1. We would times by 1, but, you know, that doesn't really make a difference in this case. Okay, so let's differentiate. So it's going to be 1 over y, okay, times dy dx. So this involves kind of that. And then the derivative, now we're going to do the product rule. So it's going to be secant squared, derivative of the first, times the second, ln of all that's in the inside. I'm running out of room, so I'm just going to leave it there. You can fill this in here. Plus, nothing changed. So it's going to be here would be the cosine of x plus 3, plus the derivative of the second. So that's 1 over cosine of x plus 3 times the derivative of the inside. So now we have to do the chain rule here. Derivative of cosine of x is times negative sine of x. Okay, the derivative of 3 is nothing, so we don't have to worry about that. And then, whoops. And then, where did I leave off? Times the first, so times the tangent of x. All right. So at this point, I'm going to leave it at that because I'm running out of time. You want to solve for dy dx, because dy dx is y prime. It is the derivative. So you'll have to move that 1 over y over, or that y over. Okay, so you have to move that over by multiplying. But remember, we have a function for y, so don't leave y in there. They gave us a function for y. So this was quite a long one. It won't look pretty, but it doesn't have to be. I think you have everything you need here, so I hope this was helpful. Good luck.